Great. So now that our hardware is set up, let's go ahead and take a look at the software. We're going to be using Energia, which is an open source, community developed development environment for the LaunchPad development kits. And as you can see, it looks probably familiar to some other wiring-based development environments you may already be familiar with. And what's great about that is that all of the same APIs and libraries can actually compile down to the various LaunchPad development kits from Texas Instruments. So in this case, we're actually leveraging a few of those libraries. So I'll actually walk through the code here. And in this case, we're including 4 different libraries. We need the SPI library, since that's the physical interface between the Wi-Fi booster pack and the microcontroller LaunchPad. We also need the Wi-Fi library, which is going to give us that fundamental interface through HTTP protocols. I'm also going to be using PubNub library. This is going to provide the PubNub's publish API that we'll be using for tossing our sensor values to the cloud. And then lastly, I'll also be using the AJSON library. And this provides a few helpful APIs for formatting JSON messages. And that way we can aggregate our sensor values and format it in a easy to digest way, so that when we send it to the cloud, we can parse it appropriately and perhaps even visualize it on some cloud-side GUI dashboards. But JSON really does enable us to send that information through PubNub in a very easy to organize way. So now that we have these 4 libraries, basically what we're going to do is program our LaunchPad to connect to Wi-Fi, connect to the PubNub server, read the sensor values coming from each of the 4 sensors that we have plugged into our LaunchPad, encode that into a JSON message, and then ultimately publish that to PubNub. So a pretty simple example here. And again, I'm going to walk through the code. So the next thing we do is we provide our Wi-Fi credentials. So my SSID and password are provided here. In addition, I also need to provide a few PubNub credentials. I need to provide my pub key as well as my sub key. And I've already created my PubNub account, and I was able to pull that very easily and copy and paste that into my Energia sketch. The next thing we need is the channel. So we need to make sure we create a application-specific channel for sending our data through. And this is going to be important when we start subscribing to our sensor values coming from our LaunchPad via the PubNub publish API. Great. In addition to that, we also have a few lines of code here for specifying which pins we actually care to read. And if we remember, we have pins 23, 24, 25, and 26 hooked up to the 4 sensors that we have physically plugged into our LaunchPad. So by having it in an array here, it'll be very easy to iterate through each analog input channel in a for loop. And that way we can kind of read the latest sensor values coming from each of the 4 sensors. So scrolling down, we start to hit the main application. So just like most wiring based programs, the sketch is broken up into 2 sections. We have the setup section and the loop section. In setup, this is where we might initialize variables, configure peripherals, and more or less set up the foundation for our application. And this setup function only runs once at the beginning of code execution. So the first thing we do is we configure our UART. UART is a serial interface between the microcontroller and the computer. And by setting up our communication interface here between the LaunchPad and the PC, it opens us up for use later on in the application for sending back diagnostic information. So once we call this 1 line of code, that interface is ready for us to use. Next, these few lines of code here are going to allow me to connect to Wi-Fi. So Wi-Fi.begin, I just have to pass in my SSID and password, and this is going to connect my LaunchPad to my Wi-Fi hotspot, and my LaunchPad at that point will receive an IP address. While we're waiting for that IP address, we're going to go ahead and print a few decimals on the terminal, and that way we can kind of see that it is progressing and it's waiting for that IP address. Once that IP address is given to our LaunchPad, we print out this diagnostic message saying that Wi-Fi is finally set up. Once Wi-Fi is set up, we can call the PubNub.begin API. And this is provided by the PubNub library that we imported earlier. Simply have to provide the pub key and the sub key. And at that point, our Launchpad will be able to connect to the PubNub server and specifically link to the account that I have based on the pub key and sub key that we provide. And then again, we use a serial.println function to print some diagnostic information. Then we'll wait for a few seconds just to let everything kind of settle down here in the setup function. Now we can jump to the loop. The loop function for most Energia or wiring-based sketches, this is where your main application lives, and anything placed between these brackets here are just going to loop forever and ever. So let's go ahead and break this down. The first thing we do is we're going to use that AJSON library to create a few JSON objects. The main object is going to be called message, and we're also going to nest another JSON object called analog readings inside of the message object. And analog readings is going to carry the 4 analog values coming from the 4 sensors we have connected to the Launchpad. So here with the AJSON.addItem to object, we're basically going to add the analog readings AJSON object into the message object. Now we're going to go ahead and get the latest sensor values and add them to the JSON message. And we're going to use a for loop. And this for loop is basically going to iterate through that array that we defined earlier. And if we remember, this array here is basically pointing to the 4 pins that our various sensors are connected to. So we're just going to iterate through that for loop, and we're going to primarily use the analog read API that Energia provides. And the analog read function here is simply going to return a number between 0 and 4095, because in this case, the Launchpad I'm using has a 12-bit analog to digital converter, and the full resolution of that 12-bit ADC gives me back a value between 0 and 4095. So I'm going to receive a number between 4095 every time I call this API analog read, and we're going to go ahead and capture that into this variable. Once I have that value, I'm going to go ahead and add it to my JSON object. And for the most part, after I iterate through this for loop, my message JSON object is going to include all of the sensor values coming from the 4 sensors we have hooked up to the Launchpad. This next line of code is going to convert that JSON object into a character array. So it's going to preserve all that formatting, but it'll provide it in a format that our PubNub publish API is capable of handling. So we need to typecast it more or less into a character array. So now our JSON object called message is no longer needed, so let's go ahead and delete it. And that's a really nice function that the AJSON library provides us with. So now that we have the formatted JSON message saved in this character array, we can go ahead and use the PubNub.publish API to send that value to the cloud. And the PubNub.publish API is simple to use. It just requires 2 parameters. First, the channel we want to send it to. And if you remember, that was defined up here. In this case, I called it Adrian's Launchpad. And the second parameter is a pointer to our character array that includes our JSON formatted message. And with that one line of code, we're basically going to toss that formatted JSON message up into the cloud. Then we're going to go ahead and free up the memory that's associated to that character array. Then we'll delay for 500 milliseconds, and we're just going to loop over and over again. So for the most part, what we're going to do is instantiate our JSON objects, read our sensor values, and add it to our JSON message, typecast that JSON message into a character array, and then ultimately publish that JSON formatted character array to the cloud using the PubNub.publish API. And again, that's going to loop forever and ever, and this will more or less give us the latest sensor values once or twice a second up into the cloud. And at that point, we can do whatever we want with it on the cloud side of our application. So we can go ahead and click on this button here, and this will compile this code and flash it into our Launchpad's memory. And since the memory of this Launchpad is flash, that means it's non-volatile, meaning that that code will stay and reside in the memory of the chip even after power has been removed from the board. So this code will reside inside of the microcontroller. So we'll go ahead and let that program. So now that our Launchpad is programmed, we're going to go ahead and use the integrated serial monitor that's available inside of Energia. And this will allow us to visualize the various messages that we're printing back to the terminal using the Energia serial.print function. So let's go ahead and click on this icon. And you can see that we're trying to connect to Wi-Fi. And once we do connect, we connect to the PubNub server. And once connected to the PubNub server, our Launchpad starts to publish our latest and greatest sensor values. And as you can see, it's properly formatted in JSON with the help of the JSON library that we used in the Energia sketch. So now that we're confirming that we are indeed publishing sensor data using the PubNub library, let's go ahead and take a look at the cloud side to make sure that these censored values are actually being sent to the cloud. So I'm going to go ahead and open up a browser here. And I've already created a PubNub account. So I'm going to go ahead and log in and go to my account page. Once you're in your account page, you'll see a link called Dev Console. And in the Dev Console, you'll be able to visualize some of the values that your Launchpad is publishing. So if you click on the Dev Console link, you'll find a really nice dashboard that will be useful for debugging purposes. You can actually verify that you are indeed receiving values from your Launchpad. So the first thing you'll have to do is ensure that you have the correct channel here typed into this field. And this will ensure that your PubNub Dev Console is sniffing the correct channel. And if you scroll down here in the messages window, we can actually see that indeed we are receiving sensor values from our Launchpad. You can see we get a really nice timestamp as well as the formatted JSON messages. In addition to receiving the real-time values coming from the Launchpad, I can also click here on the history pane. And by clicking on this refresh button, I pull up all of my historic sensor values that I've sent through this channel. So this is one of the premium features that PubNub provides, basically allowing you to have that historic sensor value or historic payload data that you're sending through PubNub. So now that we can verify that we are receiving data here in the cloud, let's try to do something a little bit more meaningful. In this case, we're going to be using another cloud service called Freeboard. So freeboard.io provides a free cloud-side dashboard for visualizing sensor data. So I've already created a freeboard.io account. So you can go to the freeboard.io website, create an account of your own, and eventually be able to create your own dashboard, and you'll be presented with a blank page much like this one. So the first thing you have to do with the freeboard.io dashboard is add a data source. And you can do so by clicking on this add button. Freeboard offers integrated PubNub support. So if you click on this drop down here, you can see that PubNub is one of the recognized data sources. So let's go ahead and click on that, and let's give our data source a name. So let's call this Adrian's data source. Here is the field for the subscribe key, and I can go back to my PubNub Dev Console here, and I'm going to go ahead and copy my subscribe key and paste it into that field. I also need to provide the channel, so I can go to Energia and pull up the channel name that I'm publishing to and paste that in. There we go. And what's cool about this is that once your data source is added, you can see a really nice timestamp here, basically showcasing when Freeboard receives the latest payload coming through that data source. So now that we know that the data source is indeed updating, I can click on this button here to add panes to my cloud-side dashboard. And by clicking on this plus sign, I get a blank pane added to my dashboard. And with this blank pane, I can add a widget, and I can do so by clicking on this plus sign. Within the drop-down are all the various widgets that Freeboard provides. In this case, let's go with a sparkline, and let's give it a name. The first sensor that I have plugged into my Launchpad is the potentiometer knob. So let's go ahead and name it potentiometer. And now I can link a data source to this GUI or to this widget, and I can do so by clicking on this data source button. And this is where Freeboard gets really cool. It's at this point exposing my data source, which is listening to PubNub, And at this point, it starts to parse the incoming JSON messages that my LaunchPad is publishing. So if we remember back in Energia, analog readings was one of the elements inside of my JSON object. And inside of that are the various pins that my sensors are hooked up to. So my potentiometer is hooked up to physical pin number 23. So by clicking on this button here, my data source is now complete, and the sensor values associated in my potentiometer knob are now linked to this Sparkline widget. So if I hit save here, we should start to see my sensor values coming through. And there you go. You can actually start to see my sensor values coming through. So when I turn the potentiometer knob here, you can see that the values are updating appropriately on the GUI. Cool. So let's go ahead and add in some of the other sensors, or add additional panes. So I can keep on clicking on this plus sign here to add a few additional panes, and you can see that I can also click and drag these things around. So let's go ahead and add a new. So let's go ahead and add a new widget type. And let's go with a gauge this time. Again, I can add a different data source, and the second sensor I'll go ahead and link up is the ambient light sensor. So let's parse through the JSON, and my ambient light sensor is hooked up to pin 24. And let's name this appropriately. And let's go and give it the appropriate min and max value. So this sensor value is hooked up to a 12-bit analog to digital converter on my LaunchPad, which returns the number between 0 and 4095. So let's go ahead and put in the appropriate min and max, and hit save. And there you go, you can start to see that my ambient light sensor values are appearing here in the dashboard. So when I cast a shadow on top of my ambient light sensor, you can see that the reading goes all the way down. Okay, let's add in the next sensor. This one is the moisture sensor hooked up to pin number 25. And let's go stick with a gauge. So here's my moisture sensor. Add in the appropriate data source and parse through the JSON. Pin 25 is the one I want. And again, let's configure the min and max number and hit save. There we go. So right now the moisture sensor is exposed to air, so there's no moisture in the air. But if I dip it into a cup of water here, we'll actually be able to see that the sensor value will shoot up. There you go. You can see that it is reflecting accordingly based on the presence of water. Now when I remove it from the cup of water, you can see that the sensor value goes back down to 0. So the last sensor that we can go ahead and add to our dashboard is the PIR motion sensor. So let's go ahead and hit the plus sign again. Let's go with the gauge. This is the motion sensor. And then again, let's parse through our incoming JSON. And this one is linked to pin number 26. And then update our min and max values. There you go. And now you can see our motion sensor value starting to come through. You can see it's kind of going crazy here because I'm not doing a very good job of remaining still. The motion sensor that comes with the Grove Starter Kit is actually very sensitive. But now you can actually see all 4 of my sensor values are streaming through and being presented in a very visual way with the help of Freeboard. So that's the demo. Just wanted to show you from start to finish how we can create internet connected hardware. So using the Grove Starter Kit, we were able to very easily interface sensors to our LaunchPad kit with a modular hardware methodology. In addition to that, we were able to use Energia and the PubNub library to publish our sensor values to the cloud. And once we were able to get those values in the cloud, we used a cloud service called freeboard.io to visualize that sensor data using a very intuitive cloud dashboard GUI building tool. So thanks for watching. You can learn more about this hardware and software setup at ti.com/launchpad, and you can download Energia at energia.nu. So thanks for watching.